Hello everyone. So today we will be doing head and neck part 2. We're skipping much of the details like the oculomotor nerve, trochlear nerve, olfactory nerves because they're not part of the syllabus this semester. So we will be continuing with the trigeminal nerve. Brain is also not included, so that is I think unfortunate but also fortunate. I don't know. So without further ado, let's jump right in. The trigeminal nerve is the major general sensory nerve of the head and also innervates muscles that move the lower jaw. Is the major general sensory nerve of the head and also innervates muscles that move the lower jaw. Okay, so trigeminal nerve, which move the lower jaw, are the muscles of mastication. It carries general somatic afferent and brachial efferent fibers. General somatic afferent, so general somatic sensation like touch or pain, etc. Just let me check. General somatic afferent. So this, yeah, pain, touch, and temperature. And brachial efferent are motor innervation to skeletal muscles derived from the pharyngeal arch mesoderm. Okay, yeah, so muscles of the like lower face, muscles of the lower face, neck, etc. Okay, general somatic afferent fibers provide sensory input from the face, anterior one half of the scalp, mucous membranes of the oral and nasal cavities, and the paranasal sinuses. The nasopharynx part of the ear, external acoustic meatus is part of the tympanic membrane. Orbital contents conjunctiva, dura mater in the anterior and middle cranial fossae. Okay, so I think it's the complete face, anterior half of the scalp, mucous membranes of the oral and nasal cavities, um, yeah, the ear, orbital contents as well. So trigeminal nerve, dura mater, anterior and middle cranial fossa. Okay, so the anterior face, the orbit, the ear, and the mucous membranes. Brachial efferent fibers innervate the muscles of mastication. Tensor tympani, tensor vela palatini, and mylohyoid muscles in the anterior belly of the digastric muscle. So this is innervated by the trigeminal nerve, anterior belly of the digastric muscle. Muscles of mastication are masseter, median and lateral pterygoids, PTER goids, median and lateral pterygoids, and the temporalis muscle. These are muscles of mastication. Tensor tympani, tensor vela palatini. We will see both of these, I think, in the infratemporal fossa or I think these are in the pterygopalatine fossa. And the mylohyoid muscles, which forms the roof of the orbital, which forms the floor of the orbital cavity, and the anterior belly of the digastric muscle. Trigeminal nerve exits from the anterolateral surface of the pons. Exits from the anterolateral surface of the pons as a large sensory root and a small motor root. Okay, these roots continue forward out of the posterior cranial fossa into the middle cranial fossa by passing over the medial lip of the petrous part of the temporal bone. Passing over the medial lip of the petrous part. 8.50 trigeminal nerve. 8.5 figure कहाँ पे है? Where is figure 8.5? Oh, this is 8.5. 2, 5, 1. Yeah, this is 8.5. Okay, so trigeminal nerve. So trigeminal ganglion passing over the medial lip. So this is the medial lip of the petrous part of the temporal bone. Yeah, I think, which makes sense. Yeah, this is the trigeminal nerve. The buttress part of the temporal bone. Trigeminal nerve gives off the three branches: the mandibular, ophthalmic, maxillary, mandibular. In the middle cranial fossa, the sensitive root expands into the trigeminal ganglion. Okay, which contains cell bodies for the sensory neurons in the trigeminal nerve and is comparable to a spinal ganglion. The ganglion is in the depression, trigeminal depression, on the anterior surface of the petrous part of the temporal bone in a dural cave, the trigeminal cave. Okay. Oh, in a dural cave. Okay, so this is not important because this is the dura mater, which is not included in the syllabus right now. The motor root is below and completely separate from the sensory root at this point. Arising from the anterior border of the trigeminal ganglion are three terminal divisions of the trigeminal nerve, which in descending order are ophthalmic nerve, which goes to the superficial orbital fissure, superior orbital fissure, maxillary nerve, and mandibular. This is foramen rotundum and foramen ovale. Okay, ophthalmic nerve passes forward in the dura of the lateral wall of the cavernous sinus, leaves the cranial cavity and enters the orbit through the superior orbital fissure. Yes. The ophthalmic nerve carries sensory branches from the eyes, conjunctiva, orbital contents, including the lacrimal gland, and also receives sensory branches from the nasal cavity, frontal sinus, frontal sinus, ethmoidal cells, falx cerebri, dura in the anterior cranial fossa, and the superior parts of the tentorium cerebelli, upper eyelid, dorsum of the nose, and anterior part of the scalp. Okay, orbital nerve makes sense. Maxillary nerve passes forward in the dura mater and the lateral wall of the cavernous sinus, just inferior to the ophthalmic nerve, leaves the from foramen rotundum, yes, and enters the pterygopalatine fossa. Ooh, okay. Maxillary nerve receives sensory branches from the dura in the middle cranial fossa, the nasopharynx plate, the palate, nasal cavity, teeth of the upper jaw, maxillary sinus, and skin covering the side of the nose, the lower eyelid, cheek, and the upper lip. Mandibular nerve leaves the inferior margin of the trigeminal ganglion, leaves the skull through the foramen ovale. Motor root of the trigeminal nerve also passes through the foramen ovale and unites with the sensory component of the mandibular nerve. Oh, okay. So mandibular nerve is mixed, but the other two are both sensory. Outside the skull, thus the mandibular nerve V3 is the only division of the trigeminal nerve that contains a motor component. Outside the skull, the motor fibers innervate the four muscles of mastication, temporalis, masseter, and lateral, median and lateral pterygoids, as well as the tensor tympani muscle, tensor velae palatini muscle, and the anterior belly of the digastric muscle, and the mylohyoid. Mandibular nerve also receives sensory branches from the skin of the lower face, cheek, lower lip, anterior part of the external ear, part of the external acoustic meatus, and the temporal region. The anterior 2/3 of the tongue. Oh, okay, so anterior 2/3 of the tongue sensory are from, yeah, makes sense, from the trigeminal nerve, which is V3. Teeth of the lower jaw, mastoid air cells, mucous membranes of the cheek, the mandible, and the dura in the middle cranial fossa. Abducent nerve is not included in the syllabus right now. Facial nerve carries general somatic afferent, sensory special afferent, general visceral afferent, and brachial afferent. General somatic afferent fibers provide sensory input from part of the internal acoustic meatus and deeper parts of the auricle. General somatic afferent. Okay. General somatic afferent, which take up sensory innervation from the viscera, provide sensory input from part of the external acoustic meatus and deeper parts of the auricle. So from the ear side, trigeminal nerve. No, this is the facial nerve. Okay. Somatic afferent. are for taste. Special afferent are for taste from the anterior two-thirds of the tongue. Okay, so facial nerve takes up the special afferent fibers, makes up the special afferent fibers of taste from the anterior two-thirds of the tongue. So anterior two-third taste is from the facial, and anterior two-third general sensory pain temperature is from the trigeminal. General visceral efferent, so give motor fibers are part of the parasympathetic part of the autonomic division of the parasympathetic nervous system, and stimulate secretomotor activity in the lacrimal gland, submandibular and sublingual salivary glands, and glands in the mucous membranes of the nasal cavity, and hard and soft palates. So this is the facial nerve. Gives parasympathetic fibers. Yeah, because this is the seventh. So 3, 7, 9, 10 are parasympathetic. Brachial efferent fibers innervate the muscles of the face, muscles of facial expression. Innervate the muscles of the face, muscles of facial expression. Okay, yeah, this is the facial nerve and scalp derived from the second pharyngeal arch in the stapedius muscle, the posterior belly of the digastric, and the stylohyoid muscle. Okay, so posterior belly of the digastric is from the facial nerve, and anterior belly of the digastric is from the trigeminal nerve. Also, muscles of facial expression, stapedius muscle and the posterior belly of the digastric, and the stylohyoid muscle. Stylohyoid. Facial nerve 7 attaches to the lateral surface of the brainstem between the pons and the medulla oblongata, contains a large motor root and a small sensory root. Intermediate nerve. Intermediate nerve contains the sensory afferent fibers for taste, parasympathetic general visceral efferent fibers, and the general somatic afferent fibers. Larger motor root contains the brachial efferent fibers. Motor and sensory roots cross the posterior cranial fossa. Motor and sensory roots cross the posterior cranial fossa and leave the cranial cavity through the internal acoustic meatus. Oh, okay. Motor and sensory roots cross the posterior cranial fossa and leave the cranial cavity through the internal acoustic meatus. Makes sense because this is the facial nerve. After entering the facial canal and the petrous part of the temporal bone, the two roots fuse to form the facial nerve. Near this point, the nerve enlarges the geniculate ganglion, which is similar to a spinal ganglion containing all cell bodies for sensory neurons. Okay, so 7 makes the geniculate ganglion. At the geniculate ganglion, the facial nerve turns and leaves the greater petrosal, turns and gives off the greater petrosal nerve, which carries mainly preganglionic parasympathetic general visceral efferent fibers. Gives off the greater petrosal nerve. The facial nerve continues along the bony canal, giving off the nerve to the stapedius and the chorda tympani before exiting the skull through the stylomastoid foramen. Stylomastoid foramen is the exit point of the facial nerve. So facial nerve 7 enters through the internal acoustic meatus, turns and gives off the greater petrosal nerve and exits through the stylomastoid foramen. Exits through the stylomastoid foramen. First, it gives off two branches. The nerve to the chorda tympani and the nerve to the stapedius and chorda tympani. Stapedius muscle and chorda tympani. Chorda tympani carries taste, somatic afferent fibers from the anterior two-thirds of the tongue. Oh, yeah, they are continuing this thing. Yeah. So this is the chorda tympani which they're talking about here. Carries taste fibers from the anterior two-thirds of the tongue and preganglionic parasympathetic fibers destined for the submandibular ganglion. Ah, okay, so the mandibular ganglion takes up fibers from the facial nerve. Vestibulocochlear nerve. The vestibulocochlear nerve carries somatic afferent fibers for hearing and balance. Ah, vestibulocochlear not included. Glossopharyngeal nerve carries general visceral afferent, general somatic afferent, special afferent, general visceral afferent, and brachial afferent. Okay, general visceral afferent fibers provide sensory input from the carotid body and sinus. Oh, okay. So this is the sensory, general visceral afferent sensory from the carotid body and the sinus. Glossopharyngeal nerve. Okay. The general somatic afferent fibers provide sensory input from the posterior one third of the tongue. Palatine tonsils, oropharynx, mucosa of the middle ear, pharyngotympanic tube, and the mastoid air cells. The anterior two-third general somatic afferent is from the trigeminal nerve. Posterior one-third is from the glossopharyngeal nerve. Sensory input. So anterior two-third special. So this was the general somatic afferent. Special anterior two-third is from the facial, which is the chorda tympani. Okay. Somatic afferent fibers were traced from the posterior one third of the tongue. General visceral afferent fibers are parasympathetic part of the autonomic division of blah 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 and stimulate secretory activity from the parotid salivary gland. So parotid gland is from the glossopharyngeal nerve. Okay, glossopharyngeal nerve, parotid gland. Yeah, but uh-huh. Brachial efferent fibers innervate the muscles derived from the third pharyngeal arch. Stylopharyngeus muscle. Pterygopalatine facial nerve. Greater petrosal nerve. Otic ganglion, submandibular ganglion. The glossopharyngeal nerve arises as several rootlets on the anterior surface of the upper medulla oblongata. The rootlets cross the posterior cranial fossa and enter the jugular foramen. Okay, this is the exit point of the glossopharyngeal nerve within the jugular foramen, and before exiting from it, the rootlets merge to form the glossopharyngeal nerve. Within or immediately outside the jugular foramen are two ganglia, superior and inferior ganglia, which contain the cell bodies of the sensory neurons and the glossopharyngeal nerve. Tympanic nerve branches from the glossopharyngeal nerve either within or immediately outside the jugular foramen as the tympanic nerve. This branch re-enters the temporal bone, enters the middle ear cavity, and participates in the formation of the tympanic plexus. Branching from the glossopharyngeal nerve either within or immediately outside the jugular foramen is the tympanic nerve. This branch re-enters the temporal bone, is the tympanic nerve. This branch enters the temporal bone, enters the middle ear cavity, and participates in the formation of the tympanic plexus. Okay, tympanic nerve I think is not included. Within the middle ear cavity provides sensory innervation to the mucosa, blah blah blah. I think this is not needed. Tympanic nerve also contributes general visceral efferent fibers which leave the tympanic plexus in the lesser petrosal nerve. A small nerve that exits the temporal bone enters the middle cranial fossa and descends through the foramen ovale to exit the cranial cavity carrying preganglionic parasympathetic fibers to the otic ganglion. Foramen tundum, foramen ovale. Lesser petrosal nerve. The vagus nerve. Vagus nerve 10 carries general somatic efferent, general visceral efferent, somatic efferent, general visceral efferent, and brachial efferent. General somatic efferent fibers provide sensory input from the larynx, laryngopharynx, deeper parts of the auricle, part of the external acoustic meatus, and the dura mater in the posterior cranial fossa. Sensory input from the throat area, larynx, pharynx, larynx, laryngopharynx, the ear, etc. Okay, the general visceral efferent fibers provide sensory input from the aortic body chemoreceptors and the aortic branch baroreceptors in the esophagus, bronchi, lungs, heart, abdominal viscera, and the foregut and the midgut. General visceral efferent, general somatic efferent, general visceral efferent. Oh, okay. Yeah, thorax and abdomen, mostly by the vagus. Somatic efferent fibers are for taste around the epiglottis and pharynx. Somatic efferent fibers are for taste around the epiglottis and pharynx. General visceral efferent fibers are part of the parasympathetic part of the autonomic division in the peripheral parasympathetic nervous system and stimulate smooth muscle and glands in the pharynx, larynx, thoracic viscera, and abdominal viscera of the foregut and midgut. Brachial efferent fibers innervate one muscle of the tongue, palatoglossus, muscles of the soft palate except the tensor and vela palatini, pharynx except the stylopharyngeus and larynx. Okay, so vagus nerve innervates palatoglossus, muscles of the soft palate, pharynx and larynx. General visceral efferent fibers are part of the parasympathetic part of the autonomic division and stimulate smooth muscle and glands in the pharynx, larynx, thoracic viscera of the foregut. Okay. Somatic efferent fibers are for taste around the epiglottis and the pharynx. Okay. Vagus nerve rises a group of rootlets on the anterior lateral surface of the medulla, which is not needed. Just inferior, blah blah blah. Rootlets cross the posterior cranial fossa and enter the jugular foramen. Rootlets cross the posterior cranial fossa and enter the jugular foramen. Within this foramen and before exiting from it, the rootlets merge to form the vagus nerve. Within and immediately outside the jugular foramen are two ganglia, the superior jugular and inferior ganglia. Superior and inferior ganglia, which contain cell bodies of the sensory neurons in the vagus nerve. Accessory. Sternocleidomastoid and trapezius muscles. Oh, it is a unique cranial nerve because its roots arise from the motor nerves in the upper 5 segments of the cervical spinal cord. These fibers leave the lateral surface of the spinal cord, joining together as they ascend, enter the cranial cavity through the foramen magnum, Accessory nerve continues through the posterior cranial fossa and exits the jugular foramen and then descends the neck to innervate the sternocleidomastoid and trapezius muscles form their deep surfaces. Some description of the accessory nerve refer to free caudal part of the medulla, blah blah blah. Cranial root, okay, leaving them in goes to the spinal root, jugular foramen. This therefore described as being as part of the vagus nerve. I don't think this is important. Hypoglossal nerve carries general somatic efferent fibers. GSC is general somatic efferent. I just have to confirm. Yeah, GSA is general somatic efferent. Efferent fibers to innervate all intrinsic muscles and most of the extrinsic muscles of the tongue. Okay. Palatoglossus, except for the palatoglossus, that is from the vagus nerve. Several rotated from the anterior surface of the medulla, not important. Passes laterally across the posterior cranial fossa and exits the hypoglossal canal. This nerve innervates the hyoglossus, styloglossus, genioglossus muscles and all intrinsic muscles of the tongue. Overview of the cranial nerves. Corneal reflex. This is not important. Olfactory nerve. Yeah, I think we're done. Oh yeah, this is important. This is the summary of the innervations of the trigeminal nerve. So you can see whatever is innervated here, here. So V3 innervates the tongue as well. Trigeminal nerve, motor root. Yeah, I think this makes sense. 4 muscles of mastication: medial pterygoid, lateral pterygoid, masseter and temporalis, mylohyoid, anterior belly, the digastric tensor, tympani and tensor, vela palatini. Okay.